Okay, hello everyone. I'm Siegfried and this is Stephen. And today we will talk about insecurity of Backend-As-A-Service. And this was joint work together with our students and Robert and Max and our advisor Eric. A few words about ourselves. I'm Siegfried. I'm a third-year PhD student at the TU Darmstadt in Germany. My main research focus is on static and dynamic code analysis, especially in the context of security, mobile security, Android security, like writing analysis for detecting vulnerabilities or malicious applications. During that research, we found various AOSP exploits and also app security vulnerabilities. We presented most of the stuff at academic conferences, and very recently we started coming to industry and giving talks at industry conferences. And so far I have to say I really prefer industry conferences because the food is much better as at academic conferences. And Stephen?
Okay, I'm Stephen, as I already said. I'm also from the academic world, also third-year PhD student at TU Darmstadt. I mainly work on static program analysis, and for those of you who have already taken a look at academic tools in static program analysis, you might know Suite and Flowdroid, both of which I'm the maintainer at the moment. And I like to play around with things and see if there are vulnerabilities and cool stuff that wasn't intended by the original developer.
Good. So why are you guys here? You're not here because cracking online banks. You're here to learn something, how easy it is to have full access to more than 56 million non-public data in the database, in the cloud. You will learn something, how easy it is to do remote code execution on Amazon services. And also you will learn how easy it is to have full VM control on Amazon services where you're not the owner of this stuff. Before coming to the point, so the presentation will be slightly boring, so we will do a short introduction about Backend-As-A-Service, and then we come to the cool part and we'll talk about this. Good. So let's talk a little bit about cloud. In cloud, you have basically three services, probably all very well known of. One is infrastructure as a service, where the cloud operator provides you an infrastructure you as a developer, and then you have to maintain all the stuff. You have to run your VMs. You have to care about everything. And it's a lot of maintenance work for you. Platform as a service is a different approach where they offer your platform, as the name says, and then you have to add your application and you have to care about your applications, right? And then there is software as a service, the smallest one, which basically is only one software, and you interact with the software usually with the web front end or whatever. And when we think about this whole concept here, these different cloud services, and when we think this from a mobile perspective, from mobile developer's perspective, it doesn't really fit into him because a mobile developer wants to have, doesn't want to care about so much about maintenance in the backend because he wants to care about the mobile application development. He doesn't want to, maintain it and set up a VM. He wants to have very easy access to the database and with ease. And therefore, some guys invented a new buzzword, which is called now Backend-As-A-Service, which will be this talk about. Good. So this Backend-As-A-Service principle basically roughly started in 2011 in Silicon Valley, where a few guys, startups, figured out that this is some new stuff, what we should do and what we should implement to make it for the developer much easier to do basically a client-server communication. There were a lot of startups and they grow very fast. And when you look into these different products, you see a lot of similarities in the code and also in the stuff. And also big players figured out that this might be a good business for us, like Amazon. But since this startup thing started very quickly to come to market, we thought out that did these guys care about security, right? So did they implement security in a good way? And this is this talk about here. We will focus on two Backend-As-A-Service providers because they are one of the biggest or the biggest. It's Parse, which is owned by Facebook, and it is Amazon, who also has a Backend-As-A-Service. During the talk, we will switch both examples, so we will see some code snippets from Amazon, you will see some code snippets from Parse, but in general, it's always the same. You can take another one, and it's still always the same. So what will we do? So now we will dig a little bit deeper into this Backend-As-A-Service. I give an introduction. Then we will talk about security. Then we will talk about our findings. And then I will hand over to Stephen. And Stephen will talk a little bit about the countermeasures. What can the developers do now after this talk? The wish list and the conclusion. OK, so Backend-As-A-Service. How does this work? You as an app developer set up or register to a Backend-As-A-Service provider, for instance, Parse or whatever. And with a few clicks, you have a complete database. You have basically a default database there. And in order to communicate, and the Backend-As-A-Service provider also, besides the backend, offers you an SDK or a library, which you have to add into your application. And with this library, there are a lot of APIs in it, which makes it very easy to communicate with the database, like to read and write and store some data in the database with only a few lines of code. And that's the principle, to make it as easy as possible for the developer to communicate with the database, for instance. Besides the Android world, there's of course also libraries or SDKs for iOS, JavaScript, Python, Windows, and so on and so forth. But the principle is always the same. So you have these libraries, you include this in your apps or in your programs, and then you can communicate and synchronize with this global database, basically. So you can have two apps, one in Android and one in iOS, and then you basically can synchronize your data there. So far, I only talked about data storage. But these guys, the Backend-As-A-Service guys, the startups, thought developers usually want more as just storage. So they also would like to have a push notification mechanism, right? So to send push notification to the clients. And for push notification, you need a client like the mobile app and the server, right? So the server sends some push notifications to the client, and the client can have it. So they already pre-installed and pre-developed this stuff. So it's for you as a developer, it's very easy to use this, only a few clicks, and then you have this. And the library contains all the code for receiving the push notifications. The same for user administration. When you develop an app, usually you would like to have some user administration, and they already, again, set this up for you. Very simple API to make this, and the backend is already created to host the users. And then social network as well, so you can very easily access Facebook or Twitter information into your app with a few lines of code. You can whatever add the Facebook profile, of course, if the user is logged in. But again, everything is very easy. So let's dig a little bit more into this SDK, and let's focus on database, right? So how does the database communication work? So in this case, we took the Amazon example, but in Parse, it really looks similar. So in order to just communicate or to connect to the database, to the cloud database, in Amazon, one example is it's only actually one line of code, and then you're connected. It's Amazon, well, in this case, an object, Amazon S3 client, and then new basic AWS credentials, and it has two keys. One is called access key ID, and the other one is called secret key. So let's look a little bit into these two. So first of all, why do you need two keys to initialize or to connect to a database? So what are these two keys? Then we looked a little bit into the documentation. And the documentation basically says these two keys are used, and now, for identifying the application, to the backend, so that the backend knows, it is this application, so I should grant access to this and that table, for instance. But interesting is, anyone who has your access keys has the same level of access to AWS resources that you do, right? This looks a little bit interesting. Then what we did, because we did really not understand, and until now we are not 100% sure what these two keys are. Because why do you need two keys for identifying something? Usually you need two keys or a username and password for authentication. Then we looked further into it, and there was one quote saying the AWS SDKs use your access keys to sign requests. That you don't have to handle the signing process by yourself. So signing, authentication, what is it? And then we found another quote. So it's not really clear what it is. Some point they write this, some points they write authentication. And then we found that the secret key, the second key, secret keys, as or the name implies, secret like your password. So this basically means, for instance, this is a username and a password. But why would you put a username and a password into your app, which is basically public? I mean, if you reverse engineer, you can access both keys. And this is interesting, so let's come to IT security class 101. And we have Peter, the client, and we have the server. So what are you doing? So when Peter wants to identify himself, he says, yes, hi, I am Peter, right? When Peter wants to authenticate, basically transmits something what only he knows, like a password or whatever. And my password is secret1234. And authorization means, okay, hi, I'm allowed to access only this and that data. Okay. So what does this mean in this backend-as-a-service principle and from what we understood? So identification is hello with the first key or the ID. Sorry, I mixed it up. The first ID. Hi, I'm app with the application ID, so the first one. And the second one is somehow for use for authentication, my secret key, but it's in the app, right? So it is really strange for us. So we think that they somehow mixed up identification with authentication. But why? Our assumption is that the backend-as-a-service principle was already used in the web world, where you have a server, where you have to protect your server, and where you can put your secret key in the server. But right now, the world changed, and you have an app, and everyone has access to the app and can extract both keys. Good. So just to make this more clear, so we have now Peter and Howard, and from this perspective, the server cannot differentiate between both because it's only identification of the app and not of the user. So this means the developer has to put on top of this, if for instance Peter puts some secret in a database, has to care about the security stuff and has to put additional effort to add security. And this is interesting. So then we looked a little bit into did developers understand this correctly, this principle here, because we are not 100% sure. And the one developer wrote on Stack Overflow, the app secret key should be kept private, so I have to encrypt it. So we can see here that they really don't understand this. Again, these two keys are supposed to be public, and you as a developer has to secure the backend in order to make this secure. And then, but the funny thing is, so he got some replies from the audience from Stack Overflow. He didn't get like, no, you got this wrong, you have to put additional security. No. Another software engineer said, yeah, definitely, you should keep these two things private. I have 4 suggestions for you. The first one was keep your secrets on some server. So put these 2 keys on the server and during runtime load them. So a reverse engineer cannot access it, right? Because it only does static analysis, of course. The second one, put your secrets in JNI because nobody really understands JNI. And it's super hard to reverse JNI. Use obfuscators, yeah, of course. And my favorite one is put it into the last pixel of your image, this information. Not steganography, what we have heard in the previous talk, like just put it there and read it from there. So you can see that these guys really did not understand what's going on. And they use security by obscurity, which is not a security mechanism. So let's look a little bit into the security analysis now. What we did, the first step, what we did, we went on the Parse website. They mentioned a lot of vendors would use the Parse library, and we found one application, we took it, and then we loaded into our own reverse engineering tool called CodeInspect, but you can use any arbitrary reverse engineering tool you would like to have. And then we found this line, and in Parse, it's not an object. In this case, it's basically initialize, a method called initialize, but again, you have to add these 2 keys into the initialize method. So it's not a surprise that you find this. And these 2 keys, so the first one, $S1, is basically the application ID, what we have learned, and the $S2 is basically the secret key, or Parse called it client ID. Secret key or Parse client key. And then what we did, we developed our own app. We downloaded from the Parse website the library, and then we also wrote Parse Initialize. We added these 2 keys, and in Parse it is special because when you set everything up, there is a default users table. It's there for you, and you can use it as a developer if you want. Most of the developers do this, and it has interesting information like email addresses and so on. So what we did, we implemented this. We took this app. And then the first one, we had access to 100,000 valid email addresses. And why valid? Because they're so nice, Parse, that there's a column say is valid, so they're verified already for us, so we don't have to verify this. And this was shocking to us, and then, we invested. So this is all manual right now, and then we invested it further, and we took a couple of more apps, like whatever, 5 or whatever, and we looked into it really to understand what's going on here. And then the result of this pre-analysis was all records were basically publicly available if we want. And only a few developers, really only a few, used the principle of security by obscurity. They tried to protect these 2 keys. The rest didn't at all. So now we are ready for a mess analysis. So we really wanted to understand what's the impact here and how big is this thing. So we developed a framework for this. And the framework takes any app what you want, whatever like you download from the Play Store. We had like 1 million apps, whatever, laying around. You don't know if there is any Backend-As-A-Service library in it. So as a first step, of course, you have to identify is there a library in it or not. So you can do this very easily by looking at the package name, for instance, because usually it's like, for instance, Parse in the Parse world. Of course, if these guys use obfuscation, then we use some very simple heuristics, saying, for instance, in this Initialize example, what you have seen, so if, for instance, if they use name obfuscation, like A, B, blah, 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 then you can look at the parameters, the type of the parameters. In the Initialize method, it was the context and 2 strings, and you can, simple heuristic, of course, if they use reflection to hide this, but none of them did. So this was really enough, so it's very easy to identify if there's a library in it or not. As a next step, you would like to fully automatically extract these 2 keys, right? And, I call it keys, both basically the ID and the key. I call it keys here. And in a few cases, the table names. So the big question is, how can we extract specific information from an application, for instance, strings, integer, and so on and so forth. So again, this was the example what we have seen previously. This is like the running example. So the first step, what you have to do, you have to identify basically the initialize method for what you would like. So you're interested in the second and the third argument, so this $S1 and $S2, because these are the 2 keys. So you first have to identify it. You can do it, for instance, with this method signature. This is notation is here a Chimple notation, our own notation of the bytecode. It's an intermediate representation. Sorry, I missed to explain this, but it's very easy to read. The second step, you would like to extract this information for $S1 and $S2, and there are different ways to do this. One way is, as we all know, static analysis, for instance. So you can start at this parse initialize method, say the second argument, so this $S2, and then you can do a backward analysis, a so-called backward string propagation if you want, and then you go backwards, and then you see, oh, $S1 equals to 3, 4, blah, 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 and then you're done. If there's another assignment, you have to go continue and continue. So this is not hard to implement. But of course, if these guys use obfuscation and so on, we all know that static analysis might not be the best case, but for what we have seen, they didn't, so it's on average, it's a very good and easy way to do this. Of course, you can do it also in a dynamic way. So how can you do this? So there are different ways. So one could be, for instance, you could instrument the bytecode with the new logger, which basically logs your information. And before this parse initialize method, you can instrument a new line which logs the second and the third argument for you. And when then you run the application with your new code, and once it hits this point, then you see it in a log output. Of course, you can also hook the stuff, use function hooking, and you hook the initialize method, and once the method is hit, then you have basically both keys what you would like to extract. But as we all know, or as you know probably, in dynamic analysis, it always has the limitation of code coverage, so this means you first have to hit the point in order to extract this information. So it's also on average is okay. Instead, what we did, we used a hybrid analysis, which basically combines both static and dynamic analysis, and then you take the best out of both and put it into this hybrid one. And this is basically the best thing. A few words, so because this is not the main part here, this is another paper what we published. We will publish soon, and this is a technical report. Our tool is called Harvester, and in a nutshell, what it does, it extracts runtime information at any position in the code. So if, for instance, for this parse initialize, you say, I'm interested in the second argument, please give me the runtime values, and you don't have to interact with the tool. Because it uses static analysis, basically a so-called static backwards slicing, to cut out and to identify all the instructions which can influence this value, and once you have this, then we directly execute it, so you don't have to interact and click on the stuff to extract this information. But again, for more information, we refer to the paper, because this is not the main part here. So, okay, at some point then you have all this information. So you, for instance, have the two keys, or the ID and keys, sorry, I mixed it all up. And for parse, there are some, you need to have the table names. You can extract the table names in the same way. For Amazon, you don't need this, but it really depends, and it's not a big issue. And then what you do, you go on Backend-As-A-Service, you go on the provider, you download the SDK, and then you basically write, you can, even for Python they have something, then you basically script it a little bit, then you add all the information as you would do as a developer, right? Add the two keys and the table name, for instance, and then you try to access the database. And this is really like 5 or 4 lines of code. It's not a big deal to do this. Good, so and then we did this, and then let's talk a little bit about findings. So first thing, so we took all the apps, we added into our framework, and then we analyzed it, and then we found out for Parse, for the Facebook, we had access, we have access to more than 56 million sensitive records. But we have to think about this. There are different apps in different categories. And these different categories use this Backend-As-A-Service mechanism. So this means, for instance, there was one app which stored accident information. So for instance, if an accident happened, you can even, like audio record, you say, blah, 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 something happened, he was, blah, 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 blah. And then you can store location information, you can store everything, what you can imagine. And of course, everything is in the backend. And of course, everything is publicly available, because these guys did not protect this thing. They thought that they are good by default. No, but they have to put additional effort on it. And the worst thing here is it's not only readable, you can also write your data. You can overwrite the data, so if you want. And well, there's a lot of virality here. For instance, pictures, user-centric location, a lot of email addresses, because this users table was in all cases there. So we had a lot of email addresses in theory. Phone numbers, contact data, purchase data, so we know if this app has some information, like Stephen owes me whatever, $10, something like this, and is stored there. So he transmitted $10 to me yesterday, whatever. And also there was an app for whatever reason, Facebook information, which stored the information about my friends, and also the friends who I blocked, which is usually not public information. But since this app stores this in addition in the backend, in theory, you know who does not like whom. Besides this stuff, which is still very serious, also the bad guys figured out that this Backend-As-A-Service might be interesting for us, right? Because it's very easy to set up and we don't have to care. We found 2 malware families that stored stolen data there. So this was a banking Trojan, so 2 banking Trojan malwares, and they stored intercepted SMS messages there and leaked data from the victim. Everything is there. Again, everything is public, and you can even modify it if you want. And the coolest thing, or not cool, is that they used Facebook's Parse library as a command and control server. So they stored all the commands, what they will attack next. So we saw basically in 3 days they will attack victim blah, 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 and they will send him a command like whatever, steal $5, something like this. So this is very serious stuff. This is another publication which where we gave a talk at Virus Bulletin, and there will be a paper about this at AVAR 2015. Good, so let's talk a little bit about responsible disclosure, because we are the good guys, and again, this is serious stuff. Before 28th of April, we had access to like roughly 100 tables and partial access to 32 tables. So why partial access? Because a few columns were actually blocked, so there was no read permission there. And roughly it was more than 56 million records, because we somehow had to count it. And 28th of April, we contacted Facebook, because Facebook is Parse is owned by Facebook. And Facebook verified it, and they asked for more data, because we sent them only a few that they understand what's going on here. And then we provided all the data what we have and from our mass analysis, so basically all the applications that could potentially, where everybody could potentially access this data. And so from our understanding, on 20th May was Facebook forwarded everything to the Parse team, and then they had to reach out the developers. Because again, it is not directly the fault of the it's not the problem of the backend-as-a-service providers. It is a problem of the developer, because the developer did not put additional security here. And then a couple of days ago, because we were curious, we scanned it again. And how many data do you think are still accessible? Exactly. So it's still 99 tables, and 33 tables are partially accessible, so we don't know. Probably it's due to development process, but it's not about and there are more data. We did not count it, but of course, since there were 3 more months, or a couple of more months after this, again, this data is still accessible, and it is very easy. And we are here not to say to the black hats, we would like to reach out to developers, because it somehow did not work to send them an email. Really care about this data, because it's sensitive data and you have to protect it. And listen to Stephen, what Stephen will say, because then you know how to protect it. Good. So a few words about Amazon. In Amazon, it's slightly different, because Amazon is like a big company. It has a lot more stuff. So for instance, there's something called EC2 thing, where you can, rent virtual machines. There's something called Elastic Beans, where you also can, run scripts there. And again, these 2 things are also accessible with these 2 keys. And if you did not protect them, if you put the root key or these 2 root keys, or I always call it key and IDs there, you can also have access to VMs. Yep. Of course, there are some developers that they didn't understand this, because, yeah. Then we had access to server backups, complete VM server backups. And again, read and write permission if you want. Well, we had access, baby growth data, very sensitive stuff, a lot of images and a lot of, a lot of content of your baby thing. A lot of photos, of course. And similar to the Parse thing, all this data. Private messages, lottery data, very funny, so you can change the lottery, but no, you can't. And a web page content, so complete web page, web servers. Since you have access to these web servers, you can, for instance, run a botnet there if you want. And again, you need only these 2 keys, and it's very easy to extract them. Good. So now, how can we protect this stuff? And I hand over to Stephen, who will explain you how to protect stuff.
Okay, so there are a couple of developers who probably don't want to give away all their data for free, all their VMs for free. So there are a couple of things you can do. So as Siegfried already said, it's not originally the fault of these backend-as-a-service providers, because many of them do offer countermeasures, just no one's using them. We'll look into why a bit later, but let me just first show what you can do. But let me first return to IT Security 101. I know most of you know, but apparently developers don't. So what you originally want is you want to have some distinction between 2 users of the app. If there's Peter and Howard, you want to say, okay, it's fine that Peter accesses Peter's stuff inside the app, but you don't want Howard to access Peter's stuff or Peter to access Howard's stuff. So those 2 is really what you don't want. And this doesn't really fit into this standard app authentication model, because if there is just the app that authenticates or identifies against the server, then for the server, there is no way to find out whether the guy sitting behind the app is actually Peter, Howard, or some script that some attacker wrote. So what you instead need to differentiate is 2 usage models of an app. So there is the authenticated user model, where you have a person sitting in front of the app storing data, and this user kind of has to identify or authenticate against the app. And you have the second model, which is an anonymous model. I just start the app, and that's it. So, and of course, in the anonymous model, I can only really work with public data. If I have an app that opens up a newspaper, for instance, we're in the anonymous case, because I don't care whether you are reading the same newspaper as I do. And then it's fine to only say, okay, I identify as the newsreader app, and I don't really care who's sitting in front of it. But as soon as you want to have the authenticated user model and you want to store private data, you have to authenticate the user all the way through to the back end. And this is what most developers don't get. So my personal assumption is that since more and more people start writing apps, and it's really easy with these frameworks, there are so many people who haven't heard about security or who mix up basic concepts, and this is why they kind of end up in the wrong model. What they have is private data, but what they end up with is the anonymous user model. And then they thinly stuff something on top of it, like look for an ID and the whole backend is public. These Backend-As-A-Service providers, they offer you ACLs as a means of providing security. But again, with these ACLs, you have an authorization model. You cannot switch between the two scenarios, right? If you have authenticated users, you can put ACLs on the back end on these users. If you're anonymous, you can put ACLs on the anonymous user. This is something you can do. You can say anonymous may not access Peter and Howard's stuff. But this means that to realize this, you need to distinguish the anonymous guy from Howard and Peter. And this is something that you must carry through to the back end and not try to solve locally on the smartphone, what most app developers try to do. So how can we do this? How can we carry this security through to the back end? If you just read the first entry you get when you Google for the Amazon Web Services documentation, you find essentially this model. You have your app, you have your ID and secret key, and you have the Amazon backend. And this is, of course, the anonymous model, right? Because I only have some identification, authentication between app and backend. But if you Google a bit more and you bother to read all of the documentation, which is a hell of a lot of paper, you find that there is actually a key hierarchy. Because when you sign up for Amazon Web Services, they give you a root account. And for this, you can generate a key, which is a bad idea. What you can instead do is you can derive accounts from this. You can say, I derive an account for app 1 and an account for app 2. And I generate keys for those. Then you can already have a model that says, okay, app 1 can only access data that has something to do with app 1. And app 2 can only access data that has something to do with app 2. So that's a bit better. And you can say neither app 1 nor app 2 should be able to start and stop VMs, because this is something that only root probably wants to do. So we're already a bit better. But we can also derive new keys. From the app 1 and app 2 account, we can derive an account for Peter and for Howard and generate keys for them, which then allows us to actually say, hey, Howard can't access Peter's stuff and Anonymous can't access any of the two. So much for theory. The problem is, if you're an app developer, you have to implement this stuff somehow. And I'll start with one technique that has been around for quite a while, and which was kind of the old way of doing it. And then I'll show you a very modern way that is came out this year. But let me start with the old one first, because applications that have been around for longer than a couple of months probably had to use this. And you're not supposed to actually be able to read this slide. What I want to show here is that Amazon had the concept of a so-called token vending machine. So the idea is you access some service, and this service does user authentication for you and gives you back a temporary ID and key. And with that ID and key, you go to the backend, right? And this is an access-limited ID and key. When another guy logs in, he gets a different ID and key from that kind of middleman. The problem is, to implement this, you need to have a client and a server side. And in the SDK, there are samples on how to create the client side and how to create the server side. But these are samples, and you had to implement the real deal on your own. So if you're just an app developer, you suddenly had to understand the concept. You had to find a way to actually host this server side, which kind of totally kills off the business model of saying, as an app developer, you only care about your app, and we do all the backend for you. And if you're a developer that is looking exactly for this, and you see this documentation and that says, okay, you get a Java server page here, and you have to host it on Tomcat or our Elastic Beanstalk service, you probably run out of the door and say, okay, why should I do this? Because my app works as fine if I just put the root key in here, right? Why should I try to go for all this effort if my app just works and this doesn't add any customer value? Next thing is, I I've been in security for a couple of years now, and actually for me it was a bit hard to read the Amazon documentation. Because let's look at this. Also, although you will need to use your AWS account credentials to deploy the TVM, we recommend that you do not run the TVM under your AWS account. Instead, create an IAM user and configure the TVM to use the credentials of this IAM user, which we call the TVM user. Oof. Problem with this is, okay, you want to store stuff in S3, which means that you have to understand S3, something called a TVM, something called IAM, something called Elastic Beanstalk for hosting the stuff. And do not confuse an IAM user with a TVM user. No, just no. So you might already see that documentation is a part of the problem. Next story is, okay, now let's assume we went through all of that effort and we have actually found a way to authenticate Peter and Howard. And now we want to put ACLs on top and say, okay, Peter shouldn't access Howard's stuff. And we started from the TVM samples. So it should be fairly easy to implement ACLs on top, right? Who thinks it is? Ah, good. Because actually the documentation says you would need to modify the provided samples in order to implement these user-specific policy objects. So these samples they provide for authenticating users, they don't even support ACLs. No. Of course, you can do all of that. But again, then you're spending at least a week, I'd say, or for me, I would count a week, to implement stuff that doesn't help you with selling your app. Stuff that you do, changes you do to your app that doesn't increase customer value, customer satisfaction, distribution of the app. For most developers, that's a wasted week, right? They won't spend it because the app runs. For not just blaming Amazon, there is a new service out now that's called Cognito that makes things a lot easier. So essentially, they now have an SDK for what used to be the client side of the TVM. They have a proper backend implementation for the server side of the TVM, and you don't have to care about that much anymore. You don't see that often in real-world apps because it's a rather new thing. And there's an interesting concept. We talked about users and authenticating users. Usually people, they want to pull out their smartphone from their pocket, start an app, and just use it, right? Because people don't want to type in some password every time. So how can you authenticate a user if the user actually doesn't want to authenticate? This is something that is called anonymous identities. So when you install the app or start it for the first time, they kind of create a fake account and store it on the phone. Of course, if the user loses his phone, that's it. Then the data is gone because the account details are gone. They're not known to the user. They're just some fake data in the phone. But it's still better than just don't using any authentication or any entities that you can use for access control. Okay, so let's just try to use the Cognito service. Once again, something from the documentation. Let me just read that out. If you created your identity pool before February 2015, you will need to reassociate your rules with your identity pool in order to use this constructor without the roles as a parameter. To do so, open Amazon Cognito console, select your identity pool, blah, blah. Okay, wait a minute. When did I create that? I think I have to look into my notes. No. So I really like the Amazon Web Service. It's great. You can do tons of things with it. And they have tons of security concepts. And they are really great. And someone did a great job designing all those things. But the problem is that most developers, they just want to get their app flying. They want to get out to market. And if you overload them with security concepts for developers that kind of, they are, let's say they are a butcher by profession, but they create apps in their spare time. Then you can't expect them to understand high-flying security concepts or assume that they are like professional developers. And that's what we saw in the examples, that people just didn't use stuff that was out there. Just to show you that this is actually pretty well designed, let me sort that out. So instead of just having standard ID and key for accessing the backend, what this Cognito thing does, it accesses Cognito using either user-provided credentials or nothing in case of the stuff stored on the device that gets injected by the SDK. You get back your temporary credentials, like a temporary ID and a temporary key, and with that you go on to a storage like S3. Such a picture in the documentation would have helped a great deal, and I think then more people would have used it. Now let's look on what you can do if you're using Parse. So Parse also has ACLs. You can configure that through a web interface. Funny enough, most people didn't even do that. So actually, I don't have an excuse for that because that is pretty easy to use. Parse also has anonymous identities. So the same story, you store stuff on the device that is then used for credentials. And the SDK automatically injects your fake credentials. Yeah, same story again. I think this might also be a reason why some people don't really want to use these anonymous identities and rather go without any authentication. Because if these credentials are stored on the device and the user loses his device, then it's really hard to get the data back. And probably the worst thing is, since these are fake identities, if I lose my device, then all my data is still stored on the server. I get a new device, and I create new records on the server. So you end up with a lot of orphaned data that is not used by anyone anymore, but that's sitting around on your disk. And there's no real countermeasure for that. And Parse charges you for disk space. So that's a small caveat to the story. Get your authentication wrong, and you'll actually pay for it because the disk runs full. One other great example of how these Backend-As-A-Service providers make it easy to do things wrong but hard to do things right is this one. So who thinks you get an error message when you try to access a table in the backend that doesn't exist? No one thinks it, or everyone's asleep? Okay, what Parse will do if you get this option wrong is it will just silently create the table for you. You mistype your table, you get a new version of the table with that mistyped name. So this is great, because what you can do is you can extract the keys from an app. You just create a new table by just specifying a different parameter in the code. You have free disk space. So whenever your disk runs full, you go to the Play Store, you look for apps that use Parse, you extract the keys, and, well, create a table. And you're not paying for it, the guy who did it wrong pays for it. I mean, this is something you would expect that these features are totally insane, but they implemented them deliberately to make it easy for developers. They didn't want a developer to have to go to the configuration system and create tables. So they just said, write the code, and we'll create the table on the fly. And this is a mindset that many of us will think is insane, but was kind of created due to ease of use. So the question now is, so it'll soon be Christmas. Let us assume that Santa Claus is coming to Backend-As-A-Service providers. What should they put on their wish list to get this whole thing sorted out? So first of all, improve the documentation. I've shown a few excerpts from the Amazon AWS documentation. This needs improvement, this needs work. Make it easier for those people who haven't had an education in computer science or IT security to actually understand what's going on, because these are the people that write apps. I mean, it's absolutely super if you have a professional developer that gets everything right. But all those apps that store millions of email addresses, or that store health records or car crash records or lottery data, they were created by just someone. And this guy, when he doesn't understand it, he will go for the simple way. And the simple way is the insecure way. Next thing is checks and alerts. So we've seen the Amazon key hierarchy, right? So there is, in general, there is absolutely no reason for anyone to ever put his root keys inside an app. Absolutely zero. But the problem is you can do it. And your app can authenticate towards the backend using a root key. And the backend will not complain. Some measures have been taken. So for instance, if you try to upload your app to the Amazon App Store, they will check whether there are keys in there and give you an alert. Double check this. Google was supposed to do something similar. We haven't seen it yet. Maybe it's still coming. But anyways, why doesn't the back end say, whenever someone with a root key connects, I'll give back a warning. I'll say, hey, you probably don't want this. And if developers during testing, they see a big message flashing up, hey, this is probably insecure, they will not ship the app like this because at the user side, they don't want this pop-up. So this would be a way to kind of force people into being more secure. But on the other hand, this might actually scare away developers because they might say, ooh, another error I have to deal with. And it's always that trade-off between getting people who are not developers to code and then getting them to do it right. Last thing, legal aspects. I'm not a lawyer, he's not a lawyer, but from what we have understood so far, there is no real responsibility for data breaches. So no one of those guys has actually said, oh shit, now we're facing legal challenges because we have made data publicly available, because we have actually given out highly sensitive user information. It's just like, maybe we should fix that app. Maybe tomorrow. So there should be some more pressure to actually properly handle user data. Okay, we're nearing the end of the talk. A few takeaway messages. So if you don't remember anything from that talk, there are 3 things I would like you to remember. First one is security in the cloud doesn't come for free. These providers, they advertise like, just purchase our service, rent our cloud space, you only write your app, we take care of the rest. But this is not how security works. Security works by you as a developer sitting down and actually thinking of what needs to be protected and what does it mean. So is this a public record? Is this a private record? This is nothing you can offload to a provider. Of course you can, but you'll fail. And then, if you get this wrong, and people get this wrong, attacks are free and almost effortless. You just put an app into Smalley, you run away with a key in most cases, and you got root access to some AWS service. And the mitigation techniques, they are out there, but we need to get people use them. Yeah, and the last one is a bit of a like a newspaper headline, secure your apps now, we're out there. Well, we're not actually hackers, we're university researchers, but I think that the bad guys already know about this because they are not stupid. And so it's a good idea to actually secure your stuff and start securing your stuff now. Okay, so that's it from our side. If you have any questions, we've got some time to take questions, and I'll be happy to hear them.
We don't have t-shirts, sorry.
And we don't give away the data. Actually, we've had a telco with them, and we've explained all these findings.
Rephrase the question.
The question for the recording. Have we contacted Amazon with a list of top 10 things to do or our wish list? Well, we've had a telco with Amazon, and we've told them about the problem. But you have to see that the general problem is a developer problem. So in the end, Amazon can just go to the developer and say, please get this right. They will not start and, for instance, deactivate root access or access with root keys, because then they will break existing apps and that will hurt their business model. Of course, we told them, hey, documentation isn't so great, and I think they're working on it. But for ultimate solutions, you have to contact the guy who wrote the code, the guy who kind of owns the data. And especially for Parse.com, for instance, they have a free subscription, a free basic subscription. So you even have apps that are no longer on the Play Store because the guy died or whatever, I don't know. But the data is still there, and no one actually feels the responsibility to delete it. Parse cannot, because it's a free service. They don't even know whether this guy is still alive or around. And the guy, of course, he doesn't care anymore. His app is not in the store anymore. He's gone. He's probably doing something else. So what about this data? It's free for everyone.
Yeah, over there.
6 million records that you
Yeah.
56 million records that you downloaded. So the servers that kept this information didn't have any kind of rate limit policy. They didn't stop you. And just seeing that you downloaded that much data from
Okay, good question. So the question was, downloading these 56 million records, which we did not, but we could, do they have any restrictions, like whatever IP things, so they check if whatever too many polls come from the same IP? Yes, they do. So they have some restriction, but they only have a restriction in the Facebook Parse. I guess you can download only 1,000 records in a row, but then you do this. They also offer you a shifting thing. So first 10,000, you can do this in an automatic way with the single IP. Yes. So there is no restriction in the backend. Yeah.
Because this question came up. We're university researchers, we're not black hats, so we didn't actually download all that data. What we did is we looked at things like counts. We looked at ACLs that were defined. We looked at schemes, like which columns do exist in that table. We had some own apps we played around with to better understand the system, but we don't have a data dump of all that data, right? Because that would be highly unethical. But these findings were confirmed, just to clarify this, by Amazon and Parse. So it's real data we're talking about, because the providers, they actually looked into the data.
Question?
When you verify that you still have access to those tables, did you basically just use the credentials you already had, or did you reattempt to access those credentials from the app?
Okay, so the question was, when we verified if we still have access to this data, to verify this, if we accessed the keys what we had, or the IDs, the credentials, or did we run the complete application again with our scanning engine? What we did, we used only the credentials, so the application ID and the key, in order to check from those what we already know if it's still possible. Yep.
Did I get it right? Facebook has wrong implemented all this stuff?
Pardon?
Is the Facebook app is wrong implemented, or
Also,
get all this Facebook information?
no. So the question was if the Facebook app was implemented wrong. No. So the Parse Backend-As-A-Service thing, which was a startup in the beginning, was bought by Facebook. And now the Parse backend thing is owned by Facebook. It's not the Facebook app. It's like whatever, any arbitrary app where you can have the Backend-As-A-Service. It's not Facebook's app. I guess they don't have the Backend-As-A-Service.
So for the Facebook data that one app included, what they did is they allow you to sign in with your Facebook account and then kind of use Facebook features. But for some reason, they took some of the data from Facebook and duplicated it into their own Backend-As-A-Service tables. So actually, when you typed in your Facebook credentials, you gave them the possibility to dump part of the stuff you had access to. And this stuff was then stored insecurely.
Okay. So the question was, how many apps did we test and how many apps did have Backend-As-A-Service? So we tested roughly like 2 million applications in total. And there are some statistics for Parse. I can tell you the statistics because they are public. It's only 5% of the apps have Backend-As-A-Service. And within this 5%, we are talking about this data. So because there are so many data, because usually these 5% are like top-rated apps usually, and most spread apps. Yeah.
Okay, we have time for one more question. Okay, doesn't seem like there is any question anymore. We're still around at the conference, so feel free to approach us, or after the conference, contact us via email if you have any further questions, and have a great day at the conference.